Day 3 is the last day of Unit 6, Transformations. So what you've learned so far, you've learned how to transform or translate a figure, shifting it left or right in the coordinate plane or up and down. You've learned also to do multiple step translations. You've been able to take a figure and you've been able to move it across a certain number of units and up a certain number of units. You learn how to reflect a figure over the x-axis and the y-axis. And you learn how to rotate a figure about the origin, whether you are rotating clockwise or counterclockwise. In all three of those things, you learn to do the math with the coordinate points to help you map the new figure. So now we're going to do the last part, which is dilation. Now, if you've ever had an eye appointment and had your eyes dilated, what happened was you had your pupil, which was about this big, see the blue dot at the top, and it was dilated so it became this big. It was expanded equally around every part. Well, that's what a dilation is. It's expanding or contracting something around any part. If you've been in my classroom, you know I have those spheres that expand and contract, and they're always compressed. So when you pull it out, you're dilating it. Well, that's what we're going to do with this. Excuse me. So dilation is multiplying by a scale factor of k units clustered around the origin. What that means is it becomes x times k, y times k. That's how you make sure you expand or contract your figure the exact same amount for every point. Okay, now we're just going to jump into the math. For the figure below, do a dilation centered at the origin with a scale factor of 1/2. So let's write the endpoints. The original figure endpoints are 4,2 and 8,2. We're going to scale it with a factor of 1/2. So I'm going to multiply each by 1/2. You can use a decimal if you wish, but fractions are always 100% correct. So let's do a little math and then we'll give the answer. This is 4 times 1/2, comma, 2 times 1/2. The left one is 8 times 1/2, comma, 2 times 1/2. 2 times 1/2. There's a multiplication symbol in there. So your final answer is, well, 4 times 1/2 is 2. 2 times 1/2 is 1. And then 8 times 1/2 is 4. 2 times 1/2 is 1. Okay, those are your final coordinates. So I'm going to draw the final figure. 2, 1, and 4, 1 becomes very small, okay? Now in the ALEX software system, you are going to have a slider, and you are going to slide it over to this part, which is the 1/2 point, so you can see, all right? But you still need to be able to do it mathematically. So this slider tells you how you're dilating, whether you're multiplying by a large number or multiplying by a fraction. So let's take a look at another one. This isn't very complicated. Now we're going to do a dilation with a scale factor of 2. Our original endpoints are 2, 4 and 6, 6. I am going to multiply each by 2. I don't think I have to write this out. I think you can do it with me. 2 times 2 is 4. 4 times 2 is 8. 6 times 2 is 12, both ways. All right, so 4, 8, and 12, 12. Gets tricky when you're looking at it really small. Okay, and again, you would move this to here, the dilation to there, all right? How you doing with that one? It's not a very complicated concept. Let's go on. All right, now we're going to do a little bit more with dilation. You've got a figure on your graph, and you're going to dilate it by a scale factor of 3 and then answer the questions. Now, if you do this in Alex, you'll be able to slide the little dilation bar to 3, and you'll see what happens. But if you're doing the test on paper, you will not be able to do that. So let's do the math, okay? Math isn't hard anyway. Mark my points and write them down. Besides, if you like to draw, you can draw a small picture on a piece of graph paper, and then you can dilate it. You can make it much larger by multiplying every point by the same scale factor. See, it is practical. 1, 3. And I've got 2, 3. And 2, 4. So, our scale factor is 3. So I'm going to multiply each point by 3. This becomes 0, 12. This becomes 3, 9. This becomes 6, 9. And this becomes 6, 12. Okay, now let's plot it. 0, 12. And it'll be easier for you to do this on Alex than it is for me to do it on paper, but just be very careful where you put your points. 6, 9. And 6, 12. Oops, forgot to complete that. All right, I'm going to connect the dots on my figure. No judging on my drawing. You know I'm bad. All right, now we're going to answer the questions. And these questions are going to show up in the software system. So the longest side of the original figure here is 2 units. The longest side of the final figure is 1, 2, 3, 4, 5, 6 units. So the longest side length of the final figure is 3 times the longest side length of the original figure. It's the scale factor because you're multiplying everything by the scale factor. You're multiplying the coordinate points by the scale factor, but you see the side length is also multiplied by the scale factor. Now let's look at the questions. Dilations with a positive scale factor of less than 1, we're going to do less than 1, gives a final figure larger than the original figure. Well, you could play around with the dilation bar, move it back and forth, go less than 1 and see what happens, but we can figure this out mathematically. If you are multiplying by something less than 1, then you are actually making something smaller, because when you multiply by 1, the thing is the same length. When you multiply by a number greater than 1, it's larger. Less than 1, it's smaller. So a dilation with a positive scale factor, meaning it's not a negative number, less than 1 gives a final figure that is actually smaller than the original figure. So that is false. All right, now let's this one. We're pulling in unit 5, similarity. The original figure and the final figure are similar. This is true because all ratios are the same. The small one, small to large, is 1 to 3. Or you could do large to small is 3 to 1. Everything is expanded the same amount. So yes, they are similar. Now, let's do this one by a scale factor of 2/3. Okay, highlight the scale factor. Now what I do want to do is remind you, just in case, when you multiply fractions, you put a 1 underneath the whole number, multiply across. 4 times 3 is 12. 1 times 2 is 2. Okay, remember how to do that. For some of you, it's been a while. All right, I'm going to write my points down. And if you don't write your points down correctly, there's no way you can do your dilations correctly. So this is 6, 9. This one is 9, 6. And this one is 12, 9. Now, we're going to multiply. So 6 times 2 over 3, comma, 9 times 2 over 3, which actually becomes 12 over 3 is 4, and 18 over 3 is 6. 4, 6. Our scale factor is 2/3, so we know this figure is going to be a little bit smaller than the original figure. Let's do the rest of the math. 9 times 2 over 3, comma, 6 times 2 over 3. We know what that is. That is 6, comma, 4. And then the last one, 12 times 2 over 3. Whoops, there's no multiplication symbol. 9 times 2 over 3. And this is 8, comma, 6. Let's plot some points. 4, 6 is right here. 6, 4 is right here. And 8, 6 is right here. Okay, you can see it is smaller. Okay, this blue triangle is smaller. It is still similar because everything was scaled down by the same amount. All right, one more page. Now we're going to transform the units. Don't forget what each transformation does. Okay, I'm going to write these down so you remember. Translation shifts up and down, left and right. Reflection changes the signs. Okay. Rotation changes coordinates. It's positive, negative, y, x. Those are just examples. And then dilation multiplies by a scale factor. So you've learned how to do all 4 of those things in this one unit. All right, let's take a look. Now you're going to analyze these pictures and you're going to determine the answers to the questions. All right, so are figure A and figure B congruent? Well, let's take a look at them. Let's see, the longest side on figure A is 3 units. The longest side on figure B is 4 units. They are already not congruent. Okay. Is there a transformation that will map figure A onto figure B? Well, let's take a look at our choices. Translate figure A to the left 3 units. Well, moving it to the left 3 units does nothing. Okay, translating it down 3 units also does nothing. Reflecting it over the x-axis, well, that does nothing because the points don't match up, do they? Reflected over the y-axis, well, that doesn't put it there. So, I'm going to get rid of some of my mess here. Last question. So we know what doesn't work. Last one. Reflect it, figure A clockwise, 90 degrees about the origin. Well, let's think about this for a moment. Figure A and figure B are not congruent, are they? There is nothing that you can do that will rotate figure A onto figure B perfectly because they are not congruent. So it's actually, whoops, none of these. Nothing will work. They are not congruent. So if something is not congruent, if the 2 things are not congruent, there is no translation, rotation, reflection, or that you can do. Okay? You cannot translate, reflect, or rotate one figure onto the other if they are not congruent. It just does not work. Get that in your brains. All right, let's take a look at a different picture. Here we go. We have to see if we can transform figure A to figure B. So you know what I'm going to do? What I've done all along. I'm going to mark coordinates. So my coordinates are 2, -2, 2, -6, 4, -2, and 8, -6. Because we're looking at putting figure A over figure B. That's what we're looking at. So first of all, if we're going to do anything to transform, to put figure A over figure B exactly, you're going to have to dilate it. It has to be dilated. Do you see that? Figure A is larger. For figure A to be transformed somehow on top of figure B, figure A must shrink. For figure A to shrink, it has to dilate less than 1. Alrighty? Scale factor. Okay, so let's check. All of these have scale factors of 1/2. So that's good. They're all still possible. Okay, that's not good. They're all still possible. So now let's look. This says translate figure A to the left 10 units and then dilate that result. Well, if I go to the left 10 units, I go from quadrant 4 to quadrant 3. And that's all I do? That's not enough. I have to dilate. I have to at least reflect. Okay? Translating left and right is not going to do. I have to reflect. Okay, let's look at this one. Reflect figure A over the y-axis. Okay, now I'm going to reflect it so that it goes like this. And then scale factor, it's still not good enough because I'm still not over figure B. I'm going to erase that one. All right, rotate figure A counterclockwise 180 degrees about the origin and then dilate. That's a choice. That's a possibility. That's going to require a lot of work. So I'm going to move on. I'm going to save that math for last. Here, the last choice is dilate figure A with a scale factor of 1/2. So I can make it smaller and then move it to the left 4 units. Still not going to be it. Whoops. So that one doesn't work. What I need to see is if this one works. Big question mark. Rotate counterclockwise 180 degrees and then dilate. Okay, let's do this in 2 steps. Step 1, rotate. My points become, remember when you rotate, you do 180 degrees, you simply change the signs. My points become, if I'm rotating, -2, 2, -2, 6, -4, +2, -8, +6. Okay, when I rotate, I just switch the signs. That's all. Now, I'm going to have to multiply everything by a scale factor of 1/2. Again, I don't even know if this is going to work, but I need to do the math. So multiply step 2. Multiply all by 1/2. -2 times 1/2 is -1. -2 times 1/2 is -1. 6 times 1/2 is 3. Then I get -2, 1, and I get -4, 3. Everything was multiplied by 1/2. So if this works, rotating figure A counterclockwise 180 and then dilating by 1/2, if it works, these coordinate points will match. So let's see. I'm looking for -1, 1, -1, 3, -2, 1, and -4, 3. It works. It works. I did it mathematically. I eliminated what doesn't work because I knew there had to be a reflection in here somewhere. Excuse me, there had to be a rotation in here somewhere. Okay? So we were able to get rid of these. The math will take you, and here's our last question. Are figure A and figure B similar? Yes, they are, because figure A was scaled down to figure B. Figure B is 1/2 scale of figure A. I repeat, 1/2 scale of figure A. So the side lengths of figure B are half the size of figure A. We kind of took figure A and compressed it together. And that takes care of day 3. So good luck with this and practice well.